Hello students, welcome to my channel Swarna's Creations and Innovations. This is Swarna. Today we are going to explain about ionization energy or ionization potential. Definition for ionization energy, IE1 and IE2. Why is IE1 is less than IE2 and explain the factors affecting on ionization energy. This is a very important question in our junior intermediate examinations. So let us get into the video. IE1. IE1 means ionization energy. First ionization energy. First is meaning of removing of first electron from an isolated neutral gaseous atom. So M is the one atom. This is in gaseous state. So we want to remove one electron from this neutral gaseous atom. By this we will get unipositive atom. So what is we are doing? M is the neutral gaseous atom. Removing of one electron, we want to use some energy. This energy is called as ionization energy or ionization potential. We are removing first electron, that's why M plus atom. So M plus atom is called as unipositive ion. So what is the definition of IE1 means? The minimum amount of energy required to remove one electron from an isolated neutral gaseous atom to get unipositive ion is called as ionization energy or ionization potential. So first electron removing is called as IP1 and IP2 means IP2 or IE2. Relevantly, we are removing one more electron from this unipositive ion. So M plus atom is here is there. Isolated neutral gaseous atom this also will be. So in this unipositive ion, we are removing one more electron to get dipositive atom. For this, we are using some energy. So this energy is called as IE2. So the minimum amount of energy required to remove one electron from unipositive ion to get dipositive atom is called as IE2. So the first concept is over. What is IE1 and what is IE2? So I am explaining again. The minimum amount of energy required to remove one electron from unipositive ion from isolated neutral gaseous atom to get unipositive ion is called IE1 and IE2 means to remove one more electron from unipositive atom to get dipositive atom, that is called IE2. So next concept is why is IE1 is less than IE2. Why is IE1 is less than IE2? So here IE2 is greater than IE1. Why this concept is came means here we will explain briefly again. So here unipositive ion is there. In this unipositive ion some electrons will be like this. In these electrons what we will say IE1 is the minimum amount of energy required to remove an electron. So here we are removing one electron. So we are removing one electron means in this electron, in this atom here first 6 electrons will be. So we are removing 5 electrons is there. So the amount of energy, the nuclear charge for this atom, one nucleus is there. For this nucleus, this having nuclear attraction. So this atomic attraction will be on the whole of these electrons. We are removing one electron, 5 electrons is there. So 6 electrons attraction is greater than 5 electrons. So one removing, we are getting extra energy. By this giving second electron also we are keeping extra energy, because attraction will be, we are keeping extra energy. So that's why IE1 is less than IE2. So this order will be like this. IE1 is less than IE2. IE2 is less than IE3. Like this will be. So the nuclear attraction more is on electrons. Applying of energy also more. Nuclear energy is less, applying energy is also less. That is the explanation of IE1 is less than IE2. And the third one is factors affecting on ionization energy or ionization potential. 5 factors is there. The first one is atomic radius. And second one is nuclear charge. Third one is screening effect. Fourth one is penetrating power. And finally, full-filled or half-filled. Half-filled orbitals. First one, atomic radius. All these here explain. I already explained this. What is atomic radius? If atomic radius is small, nuclear attraction is great. So atomic radius is large, then IP will be less. So here what we are going to set, atomic radius is greater than, IP is reversely. Is there? Atomic radius increases, ionization potential will be decreases. Atomic radius increases, ionization potential will be decreases. This will be increases, this will be decreases, this will be increases, decreases, and this will be increases. So atomic radius increases means ionization energy will decreases. And the next one is nuclear charge. If nuclear charge is heavy on electrons, we are removing electrons also very tough. That's why nuclear charge is directly proportional to the ionization potential. Nuclear charge increases, ionization potential also increases. Nuclear charge decreases, ionization potential decreases. And finally we will conclude that nuclear charge is directly proportional to the ionization potential. And the next one, screening effect. Screening effect, third one. Screening effect means, suppose, here I explained that what is this, electrons will be like that. So inner orbitals, the electrons present in the inner orbitals acts as the screens for the outer orbitals. That's why if screening effect is great, IP will be less. If screening effect is less, IP will be more. So finally screening effect is inversely proportional to the ionization potential or ionization energy. Penetrating power. Penetrating power means the penetrating power of generally the orbitals S is greater than P is greater than D is greater than F orbitals. Like this, penetrating power also, IP of penetrating power is S orbitals will be greater than P orbitals will be greater than D orbitals will be greater than F orbitals. The order are also like this only. And full-filled or half-filled orbitals. Suppose an atom like this metal, this atom in a gaseous atom. An atom, isolated neutral gaseous atom, is having full-filled or half-filled. If suppose we'll take nitrogen and oxygen. For this, having nitrogen atomic number is 7 and oxygen atomic number is 8. The electrons will be 1s2 2s2 2p3. Like this will be the atomic electronic configuration. 1s2 2s2 2p3 for nitrogen, and for oxygen 1s2 2s2 2p4. So in this we will observing here all fulfilled electrons, fulfilled orbitals. Here where these are two vacant orbitals. The ionization potential for nitrogen IP of nitrogen is greater than IP of oxygen. This is the conclusion. So why? Because of nitrogen will have the more IP, means this is having fulfilled orbitals, and oxygen does not having the fulfilled orbitals. So these are the main factors affecting on ionization potential and ionization energy. Bye students.